By now we realize that certain functions can be discontinuous, right? Any function which is not continuous would be discontinuous. But certain type of discontinuities can be removed by, doing some kind of manipulations or changing the function in such a manner that it turns into continuous. Now, removable discontinuity is something that we will be dealing with in this video. So, we have the concept of right hand limit, we have the concept of left hand limit. Right hand limit, as we denote, is the following: limit as x tends to x naught plus fx. It is essentially the limit of the function for x greater than the point of concern x naught, right? So, here, okay, this is x naught. So, all the x's coming from here, and this is the left hand limit for x less than x naught. Okay, so x is coming from this side, left side. So, that is my left hand limit. So, if limit x naught plus fx, or the right hand limit, equals to the left hand limit, but it is not equal to fx naught, or the functional value at x naught, or maybe it might so happen that the function is not defined at that point, then what happens? Then the function is called discontinuous. But we can deal with this kind of discontinuity. How? Say if fx naught is not defined, then what happens? So, let me just pick up a random function, x square minus 1 upon x minus 1. Clearly, can you guys see that this function is not continuous? Now, why? Because this function is not defined at x equals to 1. So, discontinuity I am talking about x at x equals to 1. This function is just not defined because the denominator would be 0, right? So, the function f1 is not defined. So, in that case, this function is not continuous. Now, that is because there is a hole in the graph. At 1, there is a hole in the graph. Okay, this should be 2. So, there is a hole in the graph here because the function is not defined. But this kind of discontinuity can be dealt with. Just carefully look at what this function will almost look like. I can open up the numerator. So, this function will almost look like the function x plus 1. So, we can take a new function x plus 1, gx equals to x plus 1, and that would be a continuous function. And that would be a continuous function. So, what we can do is we can just fill in the gap. We can just fill in the gap and we can do away with the discontinuity. Okay? Because what will happen then, from left hand side, right hand side, and at 1, the limit will be 2. So, my function will be continuous at this point.